What's up today? We're going to talk about operations with functions. And so we are starting off with lots of blanks to fill in. There's some vocab from Algebra 1 you may or may not remember. So here we go. A relation is a set of ordered pairs, meaning that it pairs inputs with outputs. So plug something in, we get something out. So it is. Some of you may have learned about like a function as some sort of machine at some point in your pre-algebra or algebra 1 days. In an ordered pair, the x represents the input, which plug it in, and the y coordinate represents the output. The domain of any relation is the set of all inputs or x values, and range of any relation is the set of all outputs or values that that relation takes. Now there's a special type, however you want to put it, of relation called a function. We love functions here in algebra. A function is a relation that assigns exactly one at each input. So this means that each value in the domain corresponds to only one value in range. Each x is only one y. All right, this is what function notation can look like. So in this function notation, f, this whole thing, this is notation. This does not mean f times x. But this whole thing right here is the output y here dressed. Reason being, this x here tells us the inputs. It's the same as the x flipping around over on the right-hand side. And that's nice because it can tell us what is our function, which is super handy. And this part is known as the function rule, right? So it tells us what happens to our inputs after they're inserted into our function that makes them into our outputs. All right. So when we are considering the graph of a relation, we use the vertical line test to determine whether a relation is a function. If the line passes through more than one time, then it is not a function. All right. So I ran over a little bit there. I'm not entirely sure what happened with my words because they look fine on my copy, but I'll make sure your fresh copy looks much better. All right, so example 1, are the following relations functions? So what we're going to do here is that vertical line test. So we're going to draw a vertical line. And of course my pen skipped, so to get to the fancy straight line. Oh, come on. It keeps skipping on me. I don't get to do my magic trick that way. One more time. There, so there's my fancy vertical line here. And what I'm going to do is I'm going to move my vertical line all along the graph. And so like see right here at the vertex of this graph, it's only touching one point at a time. But oh no, as we go, you'll notice it's touching my graph in more than one spot. So right here is that this guy fails the vertical line test. So no, this guy is not a function. Is my explanation. I'm going to say he fails vertical line test. Right, next. So this is a mapping diagram. So it shows you my domain, and then there's arrows showing what things are going to in the range. And so right here, notice 6, 5, and 7. Oh, we can't have that, right? So no, this is not a function because 6 has 2 outputs. All right, and next is a table. So 2 has 1, 3 has 1, 4 has 1, 5 has 1 output. Okay, it's okay to share. That's totally fine that those have the same y value as long as 3 isn't mapped into, say, 31 and 32. So finally, yes, right, this is a function because each x has only one y. Okay, so now that we've kind of refreshed our memory and all this vocab, let's remind ourselves of some operations with function notation. So we can combine functions with adding, subtracting, multiplying, and dividing. And that's going to help us make new functions. So there's 2 equivalent ways, though, to rewrite each function operation. And you're going to see me utilize both. So you're going to see me write f of x plus g of x, or f plus g of x. So addition and subtraction, multiplication and division. With division, of course, we have to be mindful that our denominators aren't being 0. Those are 2 different ways that we can write. And as you can see here in our examples, I'm using both of those forms of notation. All right, so what we've got here is given f of x equals x minus 4. So I like to color code my function. So f of x equals x minus g of x is 2. Each of x is 1. We're going to do the following. So f plus g at 1. So right, again, this is just notation here. This isn't any multiplication, though we could rewrite this as f at 1 plus g. And then what I'm going to do is plug those in. So f at 1 means I'm going to have 1 minus 4 plus g of x looks like going to be 1 plus 2. So 1 minus 4, that's going to be -3 plus 3 or 0. That's right. Next, we've got f minus h of 4. So again, this is just notation. Here, this means f at 4 minus h at 4. So put this in. F at 4 is going to look like 4 plus 4 minus 4 squared plus 1. And so this is the 0 minus 4 squared is 16 plus 17. So this will be -17. Hopefully we don't have 0 going on. This here means that we're going to have h at 0. So this is going to look like 0 squared plus 1 all over g at 0. So g at 0 is 0 plus 2. So this is equal to Okay. So now the rest of them are all in terms of x. So rather than plugging in for a specific value of x, we're going to leave everything in terms of x. So when we do f of x plus h of x, I'm just going to write in my functions, right? So f of x was x minus 4, adding to that x squared plus 1. And so what happens here is we're just going to combine any like terms that we have, answer in standard form. So we start with x squared as our leading term, plus x, and we had minus 4 plus 1, so it could be minus 3. So teach my students, if in your problem it says f plus g of 1, and you see that we are evaluating for specific x value, we know our answer is going to be some sort of constant, like 0, negative 17, or 1/2. If our notation says, like in question D here, f of x plus h of x, and we see that x is what's in our notation, then we're going to see x's in our answer. Unless, of course, everything happens to cancel out. But for the most part, we'll see x's in our answer. Right, next we have h of x minus g of x. So h of x is x squared plus subtracting that gx, which is x plus 2. We're not going to forget to distribute that negative, so we're going to have x squared plus 1 minus x minus 2. So we combine my like terms, I'll have x squared minus x minus 1. So f times h is as f of x times the whole function f of x, which was x minus 4, function h of x, which is x squared plus 1, and then we're going to have to FOIL or double distribute. X goes to x squared, x goes to 1, x cubed plus x, minus 4 goes to x squared. We'll just rearrange this to the standard form. So no, I don't write over there. Keep all of my work up and down here. Alright, so the piece of ground for day 2. I'm going to teach you a new operation that we can do with functions. Bye.